Hello. Today I'll be showing you how to do function transformations intuitively and systematically, whether that is graphing the function, describing the transformations, or plotting a table of values. Let's start off with something simple. Y is equal to 2 to the power of 2x minus 4. The parent function for this is y is equal to 2 to the power of x. I have the subscripts 1 to avoid confusion. Now I will finish the table of values for the parent function. Now, pretend for a moment that you have to get 5 points from the function 2 to the power of 2x minus 4 without doing any arithmetic or calculations. The only thing you can use is a table of the parent function. What would you do? Well, as you can see from the parent function, 2 to the power of negative 2 is equal to 1 over 4, and we could use that here. If we set 2x is equal to negative 2, then 2 to the power of 2x is equal to 2 to the power of negative 2, which we know is 1 over 4. So when x is equal to negative 1, 2 to the power of 2x is equal to 2 to the power of negative 2, which is equal to 1 over 4, and thus the y value is 1 over 4 minus 4. Let's try another example. We see from the parent function 2 to the power of negative 1 is equal to 1/2. So if we set 2 to the power of 2x is equal to 2 to the power of negative 1, we get x is equal to negative 1/2. And when x is equal to negative 1/2, 2 to the power of 2x becomes 2 to the power of negative 1, which is equal to 1/2. So the y value then becomes 1/2 minus 4. Now let's try the last example. We see from the parent function 2 to the power of 0 is equal to 1, so if we set 2 to the power of 2x is equal to 2 to the power of 0, we get x is equal to 0, and what this means is when x is equal to 0, 2 to the power of 2x is equal to 2 to the power of 0, which from the parent function is equal to 1, and thus the y value is equal to 1 minus 4, which is equal to negative 3. Now this is getting a bit tedious, isn't it? So let's develop a formula. So from the parent function, we have 2 to the power of x1 is equal to y1. And like before, we're going to set 2 to the power of 2x is equal to 2 to the power of x1, which gives x is equal to x1 over 2. And that's it. That's a formula for x. Now what's a formula for y? Well, if we substitute x is equal to x1 over 2 into the equation 2 to the power of 2x minus 4, we get this is equal to 2 to the power of x1 minus 4. And 2 to the power of x1 minus 4 is the same as y1 minus 4. So the equation for y is equal to y1 minus 4. And let's do a few more values. If we set x1 is equal to 1, which gives y1 is equal to 2, then we can substitute this into the equation. x1 over 2 is equal to 1/2, and y1 minus 4 is equal to negative 2. And lastly, we have x1 is equal to 2 and y1 is equal to 4. Then we get x1 over 2 is equal to 2 over 2, which is equal to 1, and y1 minus 4 is equal to 0. Using the table of values, you may graph the function. However, I don't want to do that, because all you have to do is plot all 5 points and connect them together. Now we will describe the function transformations. We will do this using the formulas we have developed, which is x is equal to x1 over 2 and y is equal to y1 minus 4. x1 and y1 are kind of the original values. Now, it doesn't matter which transformation you start off first, whether that is the x transformations or the y transformations. I'll start with the x first. As you can see from x is equal to x1 over 2, x must be half of the original x value in order to have the same corresponding y value. By the corresponding y value, I mean the value of y1. So basically, when x is equal to x1 over 2, that is when 2 to the power of 2x is equal to y1. Thus, the transformation for x is a horizontal stretch by a factor of 1/2. You could also write a horizontal compression by 2, but to avoid confusion, a factor of 1/2 always does a trick. To describe the vertical transformations, we look at the formula for y. We see that y is equal to y1 minus 4, which means y is 4 less than the original y value. And so, consequently, it is a vertical shift down 4 units. In the next video, we will describe a more complicated function transformation. And if you have enjoyed the video, then praise the Lord Xiang